Fair warning, there are times when you think that you've programmed this, but you've actually commanded this. Oh yeah. So stick around. We're going to show you some special cases where your programmed feed rate may not be giving you what you expected. So we've got solutions for you in this Haas tip of the day. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up. Now if you're tightening up those tools by hand, geometry. We all love geometry. Okay. I love geometry. So what we've got here are two circles, one big and one small. Now they've got different size diameters, right? They've got different size diameters, big diameter, small diameter. And they also have different circumference, the distance around those circles. What you will eventually find out is that when you program a circular pocket with a tool that is nearly the same size as the hole itself, your effective feed rate might be 10 times higher than what we had thought. You might end up with this instead of this. Now, this happens because our tool thinks that it's going this far when it's actually going this far. If you see this, and you will eventually, it's because our programmed feed rates are based off the path the center line of the tool follows, and not the path that the edge of the tool follows, which is much larger. Here is the hole that we want to mill at 550 thousandths of an inch in diameter, about 14 millimeters. That's this outside black line. We're going to mill this circular pocket with a tool that is 1/2 inch in diameter, 0.5 inches, 12.7 millimeters. 550 minus 500 gives us 50, 0.05 inches. Now that's going to be the circle at the center of our tool that is created as this tool moves around to create the pocket. That's where our feed rate is programmed from. At the center of our end mill, our tool is programmed at 30 inches per minute, F30. But that's at the center of our tool. Out here at the edge of our tool, where we're at the 550 diameter, things are moving much faster, 11 times faster, because 550 divided by 50 equals 11, 11 times. This outer circle is 11 times bigger than the inside circle that our feed rates are based on, and we haven't adjusted for that. Here, we'll show you this in a different way. I've loaded up an 11-inch bar of steel, and we're going to show you what machining just that first 1 inch would look like at a reasonable feed rate. Okay, so that was normal. Let's cut 11 inches of steel in that same amount of time and see what that looks like. Not good. We're going to need to compensate for this, and we've got a few solutions. Solution number one, which is always my first choice, is to see if your cam system can compensate for this automatically. Now, some cam systems, like Mastercam, can override arc feed rates, adjusting the feed rate on every inside corner if you'd like them to, changing the feed rate on every G2 or G3 arc move within a set range. Now, this is a nice feature, but if your cam system can't compensate for this, it's not the end of the world. In my experience, this is only a big deal when milling circular pockets with big end mills or when thread milling. And now that we know what to look for, we can compensate for this manually. Ready for the formula? Machinists love formulas, so here we go. Feed rate times hole diameter minus our tool diameter, all divided by our hole diameter. And we know from our example earlier that we want our feed rate, our effective feed rate, to be 30 inches a minute. So F30 times our hole diameter, 550, minus our tool diameter, 500, all divided by our hole diameter again, 550. Now if we do the maths and we fill in all the blanks, we're going to end up with a feed rate to be used in our program of F2.73 inches. Now with that F2.73, at the center line of our tool, we're going to end up with an effective feed rate of 30 inches a minute where it matters, at the edge of our tool. So if our hole diameter is 11 times bigger than our tool path diameter, then we need our feed rate to be 11 times smaller. We'll see this type of feed rate error all the time when thread milling, when posting our programs from a cam system. Our thread mill is moving much faster at the edge of the tool than it is at the center of the tool. Now we can use the same formula to adjust our feed rate for thread milling. We just replace our hole diameter with our major thread diameter. So can the control do any of this compensation for us? Well, it can, but it's got to know what your tool diameter is. So typically, usually, if you're programming by hand, you'll just hand program to the part contour, and then you'll enter in the tool diameter on the tool offset page under diameter geometry. And then when you call up cutter compensation, the control has everything it needs to slow down feed rates in tight corners. This works together with setting 44. It gets really complicated, but just know that if you're using cutter compensation and entering your tool diameter, it is slowing your tool down for you in those small radiuses. But most of us use a cam system to program our parts. And when we program a cam system, we let it do all the heavy lifting. And then all we enter on our offset page is our diameter wear, our wear geometry, usually a small number. And we let the cam system adjust all of our feed rates. The other option is to compensate them by hand, like we showed you earlier with those formulas. Well, that is all we've got for you this time. Thanks for letting us be a part of your success and for watching this Haas Tip of the Day.